Welcome back to the.
Yeah. Oh,
Thank you. Welcome back to the Functional Features. Today we're joined by Tim McNamara, a Rust evangelist, a data scientist, and author of books that are residing on the bookshelves of many Rust neophytes and advanced users alike. And hopefully, I know I am. They are also putting those books to good use and actually learning Rust. So. Hi Tim. Thanks for coming to our show.
Hey, thank you so much. That was a very warm introduction. I have been very surprised is the wrong word. I'm so thrilled whenever I see someone saying something like, I read your book and I learn a lot." And when you write these things or you spend hours and hours and hours in a project like this, it's very difficult to imagine what things will be like once it is complete. And no, it's been amazing to see how well it has been received.
Right. We'll touch on the subject of writing, of putting spoken word to paper a little bit later. I guess let's start our podcast with probably the least conventional thing one can do in a podcast, which is a live coding session. So I don't know if you know, but in our podcast and the Functional Features podcast, we have this kind of running gag that I personally don't know how to implement the breadth first search in Rust, perhaps there's literally no better way to kind of crush this meme and show that it's not all that scary. No better way than by having you do that, especially given that we know that you have a kind of prolific and pretty diverse YouTube channel yourself with live coding sessions, and you also post there how-tos and tutorials, as far as I understand. So
well, I hope that this works, because the problem with doing things live is that things don't always work. However, I'm up for the challenge. I think that it will. I'm sure it will be interesting to see whether or not I can explain things in audio while coding, with you asking me questions at the same time. But let's find out. I think it's an interesting challenge as well, because graph algorithms stress or make graph algorithms actually the hardest to implement in Rust because of its ownership rules, and requires Rust really cares about where references to other bits of data are. And so if I just create I'm not making any sense, sorry. I'm just trying to type and talk, which isn't useful. But what we're doing breadth first search. So if I create a file, bfs.rm.rs, and I want to create a function in there. Let's say.
I guess I can give you a little bit of typing space, and I'll try my best to kind of articulate what you meant there. Is that this is something that I personally struggled with a lot, because I couldn't implement breadth first search in Rust, not for the lack of trying, right? I tried 3 or 4 different attempts, and my 4th attempt, I guess, was just full of RCs and reference counted memory chunks, and that the big issue for me was how to actually kind of unify this dichotomy between me wanting to traverse a graph and perhaps get kind of wire the reference to that graph from one level of recursion to another level of recursion, and at the same time complying with ownership rules. And as you mentioned, sometimes mutability also comes into play, because I want to actually maybe do something meaningful, right?
Yeah.
And just these 3 things for a beginner, they don't go well together. Okay, so let's get.
Okay. yeah, so let's just start with not really we don't really understand our algorithm, but we've created a function here, BFS, that takes some graph and a start node. Now the question is, what is it? What representation do we want? And I'm actually going to pick a trait because traits enable us to model abstract data types quite nicely. And one of the things that we will try to do is also create an associated type node. Now, the compiler will eventually complain that I haven't done things correctly, but in my function, so we'll need to add some constraints to this. But for now, what I want to say is that for a graph G, we have a start node, and the type of the node of the type of the start variable's type is the associated type of graph, right? So these two types are somehow interlinked. If I were to look on Wikipedia, say, then I would kind of look and have I require a queue. One of the things about breadth-first searching, we're going and we're adding something to a queue, and then we are going to explore it. And if we've seen that node, continue, skip it. And if we haven't, add things to a queue. So we need to start with a queue. So I'll use, I think it's in standard collections. So it's std collections. There's this thing called a vec deck, which is a double-ended queue. And which is backed by a vector. So it's growable, it shrinks and expands. I need to add, so if I create a variable with that's mutable, and let's call this q, and my vec deck. Oh, I've made a.
So this vecdeck is you said that it's a double what queue? So how is it different from like just normal vector? Like
Right. So double-ended, which means we can add things or remove things from the front or the back. So a queue, if you were to think about it, if you were standing in a shop line, we add things to the back, but we take things off the front. Yeah. And in the data structure sense, this is, we need those operations. We need to be able to pop off the front and just remove things from the front of the queue, but add things to the back of the queue. Now, we haven't actually explicitly said which type we are going to hold inside our queue. We're going to allow type reference to do this, but in a sense, you could imagine that it will be, the queue will be of, its nodes will be of type graph node, where graph node is the associated type. Now, I also need some data structure which will hold nodes that I've already seen. And so I'm going to use a set for that. And it's also in the standard collections module. I've got a hash set data type. Now, a hash set requires a hash function, and I'll create so new visited is hash set new. And the first thing that I want to be able to do, I can sort of add to, I need to be able to actually constrain the type of node. Visited will include nodes. And I want to add a couple of constraints. One is I need the node to be able to be hashed. Otherwise, it can't fit inside a hash set. I also want my node type to implement equality. Otherwise, I can't check whether or not I've already visited it. So the equality trait will require that, will enable me to be able to check whether or not some node that I'm visiting is exactly the same node that I've got in
in the set, yeah.
Yeah. Okay. And I also want to do something sneaky. some people may think this is cheap. I think it's useful. I want my nodes to implement clone. Clone, by the way, implies copy. Clone and copy are two traits which enable a type to copy itself. Unlike Java, for example, the clone operation always works, and it's well defined. And one of the things that I want to be able, so now my queue and my visited variables can do things with nodes. There will be one more change to graph that I need to make, and it relates to this ownership or borrowing concept that we've touched on a few times. Normally, let's try and I'm just copying the implement there's a Wikipedia. I want an enqueue, and I want to enqueue the start. And this is probably the wrong syntax. The compiler will complain very quickly. And I want while there is something in the queue. I think I'll just actually just double check the.
I think it's pop front for queue.
Yeah. Probably an underscore there as well.
Yep.
And I misspelt that as well, but that's just because where is my cursor? Over here. Pop. So I've got a loop where every iteration I'm popping something off from the front of the queue, and now I want to be able to see. And so the node variable inside this loop is the item that is at the front. Now, normally when you are searching, there's a target node. So we can, but in this case, we actually have got no way of describing our goal. And so we could say or just add a comment that if we have found our goal, return here. But in this implementation, it doesn't actually matter. We'll just traverse the entire graph.
Yeah, that's obviously good enough.
Okay, right. Now, for every... so the next step is for the other nodes. And let's say... actually, I'll change this other to something that's a little more concrete. Neighbor. In node edges, let's say. Now, I made a mistake here. I've left out a bullet. This is where people often get stuck when they write Rust. In this case, in my function that in the code that I've just written, I've got the node type, and I have called a method outNodes, or it's like, what are my neighbors? Well, what am I connected to? Return those. Rust will complain a lot about this because of the way that references work. If you were to consider some type of data structure node that knows about its own nodes, its own neighbors, and has references to those, then you create a chain of references all the way through the entire graph. And the borrowing system will require that some nodes own other nodes. And that won't really work because they sort of no particular node of a graph owns the other nodes. And so they all live and die at the same time. So we actually need to change our function. Well, we need to change how we do this. We need to say that the graph itself can describe the neighbors of any given node. And because we only need like read access, we'll take a reference to our node. And then
and this, sorry to interrupt, and this this situation is also very obvious, for example, in doubly linked lists. It's like the perfect example of what Tim is talking about, because then literally for no single element, you can't say, okay, like which element owns which of its neighbors, right? Because like if element A owns neighbor to the right, then like then eventually you will loop and you will get kind of contradiction, right?
Absolutely. Absolutely. And this is a problem because that's a complete problem, because Rust's compiler will say this is it's sort of infinitely recursive, and therefore I cannot it's undecidable. And it's sort of an impossible thing to check.
And with doubly linked list, you will use the same trick, right? You will create like an extra kind of entity, and then you will delegate all the ownership to it.
Yeah. So in the case of, say, something like that, you will have often you will have a list struct or some list type, and it will have elements, for example, or nodes, and you can think of the list as kind of a manager, perhaps, or something, and it owns all of its nodes in the list. Now, one of the things that needs to change in my is the graph trait. So we are relying that this graph object has a neighbors method. Now, so I need to actually encode that in the type system. So I define a function neighbors that takes a read-only, or it takes a reference to self and a node, and a reference to a particular node. And I would say it's a reference to the same type of node that the rest of the graph has, and returns some list or some vector of self node. Now this will, just the way that the type system works is that this is an abstract, the trait is abstract, and so we actually don't need an implementation, but the compiler will still be able to reason about this for any given implementation. Okay. Right. So
yeah, but by the way, just for the listeners, I want to say that basically what Tim typed out right now was essentially something resembling, if you know Go, for example, a receiver function or receiver method. I don't quite remember how they are called there, where basically it takes as a first kind of argument, quote unquote, well, literally argument, that takes a reference to some object, some structure, something, right, and then you can call it with like dot notation. You can write like your graph dot neighbors, and then give a reference to a node there as the only argument, as the only kind of visible argument of this function. Then, and what is interesting for me as a beginner in Rust is that Tim used notation of ampersand capital self colon node when talking about the node argument for this abstract neighbors function. So this is something that, it clearly refers to, like, my question is, I guess, why didn't you write graph colon node instead of self colon node?
That is a so that's a very good question, and I think it's mostly related to aesthetics. So I could have definitely said that my neighbors method takes its nodes are of graph node. This will still work, and but the capital S self is a type variable that relates to the type that the object is, and it appears in a few places. So I'll just and particularly you might see a new method. Well, it's often a static method. So I'll just quickly expand on what I'm talking about. So if I've got some struct, and I'll just call it just n, and it has an I32, so an integer. And I have got an impl block, and I want to implement methods on the type. Oh gosh, just making typos every single line. And I want to create a method on n. You might see a new method being created that takes no arguments but returns capital S self. And this will occur in the, let's say, it will just return some default usually. And in this case, I'm just returning the 0. Or,
Wrapped in n, yeah.
Yeah. So that's another place where it will occur. Inside a trait definition, you might see self often. One reason why you might wish to do it is because it enables you to change the type of the trait. So instead of saying graph, you might say nice. You might or yeah, so we can change we can refactor the name of our trait without affecting the signatures of any of its methods.
Yeah, but maybe also like again, like kind of intuitively, perhaps it's wrong. Maybe, but like maybe if you just left graph there, then it would allow me as a user of your code to actually take one type that is a graph, like that implements graph, and then actually trick it into accepting another type that implements graph. Or it would be, I think it would be possible, right? I'm not sure. Like if we would left graph instead of self in the type definition.
Yeah, you can. I have confused myself before doing something similar, and I don't know if this is what you're saying. But one of the things that I did, what I've done before, is create a struct node, and in one of these arguments, I had both the concrete type node, which was and also I was referring to the associated type node inside the graph, and that caused some problems. However, yes, you could potentially, you can. Let's say that you wanted to have an arbitrary node type. I'm going to just, we can actually insert a type variable. And for some reason I said, I'm going to give it the type variable v for as vertex, because we've used the term node several times already. And then I might say that this requires hash equality and clone. And so for anyone, if you're only listening on audio, I've just replaced the associated type with a generic. And this is possible too. It just changes the way that it changes it makes it a little bit more complicated to call, I think. But there is a good reason why sometimes you use associated types and sometimes you use generics, but I'm forgetting it right now. But right. So neighbors accepts a reference to some node type, which is which implements hash equality and clone and returns a vector of the same. Now, the difference with the problem that you might encounter if you define graph like this is that there is no guarantee that you can, that the type system cannot guarantee that the nodes that are being received or returned relate to the graph itself. So you could trick it into accepting the wrong type of graph, the wrong type of node. Whereas with an associated type, the type system itself, the compiler will actually say, no, you can't give me a node from some other graph like that or some other type. I actually require the type that you've that's been defined for you. And so
yeah, that you're writing implementation of currently, perhaps. Yeah, this is actually something I was like almost sure about. This is what the nature of the question I tried to ask was that the way you wrote it in the first place with like capital self is actually kind of the most type safe way to approach it, because then you constrained like what can and can't be done. Sorry for derailing it a little bit into like the matters of type safety and whatnot.
No, it's perfect. And I mean, the I enjoy having to think anyway. It's actually really interesting that because the notion of type safety and the value of a type system is something that I never appreciated until I started programming in Rust. So I see Rust as the kind of this middle ground between Haskell and, let's say, Java or C# or something. I was a Python programmer beforehand, and I did not care about type safety at all. And I did not understand why I needed a compiler even. But after using it, I've just become so reliant on the guarantees that are provided by a strong type system that I find it really difficult to go back to other languages now. Okay, so we're back inside our breadth first search. Now, we've got for every neighbor in the neighbors of the node. If we've already seen it and visited, if visited contains neighbor, then we skip to the next neighbor. That is, if we've already seen the node that we might want to check, we don't need to do that because we've already done it. We also want to be able to, and the next thing we'll add is we'll insert neighbor, because we actually would rather not visit neighbors twice or an infinite number of times. Okay. And the other thing that we need to do is our queue. We need to enqueue neighbor. Now, do you remember right at the start, I said that I was cheating a little bit? One of the things that I said is that I required the clone trait. And so I've got two methods here. One says queue enqueue neighbor, which says, please add my neighbor to the queue of things that I wish to search. And also insert neighbor into the visitor set, the visited set. Actually, that's wrong. I need to
the node, I think.
Yeah, I need to. I need to insert visited, the node into visited. Otherwise, I will. That is breadth first search implemented, I believe.
Yeah. And we will traverse the entire thing now. Yeah, I wonder if Rust if Rust compiler will agree with us about it.
So now you want me to implement on a concrete type? Okay, let's try. So now the question is, okay, Tim, prove it to me. And so I want some struct the. Okay, so now I actually need to do this. Right. So one of the things that I need to do is I want to have a structure, and I'm going to call this, let's say a a maze. This was actually first implemented by Konrad Zuse, I believe, in the late World War II, and it was related to to path searching. So it anyway.
Like the law of left hand or something.
Yeah,
like how you can traverse a maze by
just
touching the left wall or something like that.
Yes, yeah. So this is one of the ways to be able to search through a maze. Well, in fact, arbitrarily, you should be able to find any a root, if two nodes are connected in the graph, breadth first search is guaranteed to find them. It's not the fastest way to do so. And in many ways, especially if you have many branches, is a very slow way to find paths between two nodes. But it has the advantage that if your graph is of infinite size, it will complete. Whereas depth first search has a problem, and that is if your graph is actually infinite, it will actually never complete. It may never find the connection. It will always get stuck. And so in practice, depth first search often has extra termination rules that don't really apply in the theoretical computer science case. Anyway, so we've got our maze, and I'm just going to say at the moment that it has nothing inside it. And so we are going to do something which is going to look a bit strange. We need to implement graph for maze. And I'm going to do it in a way which is probably going to make you both, or anyone listening, kind of angry with me. Well, maybe not. Which is to say that so I need to have my type node, and we'll just say it's an I32 because that's a nice. We could even say that if it's a XY coordinate, it could be a tuple of two numbers, and that will work as well. Now I need to implement neighbors for graph. And so let me just check what it is. It takes a node and it returns a vector of nodes. Okay, so
by the way, this is another reason for using type systems, right? Because like you're stressed. Some guy
that's right.
Some guy asks you to like live code in front of live audience.
Yeah, absolutely.
If it was like JavaScript, you could have forgotten by now what neighbors are already. But like
absolutely. So this is I32. Now we could have created a type alias for this tuple type, and I think that, and we return a vector of I32. I think, by the way, if it's not obvious to anyone, this is actually real. So I don't actually have a demo of. I'm not copying this from anywhere. I'm actually, it's genuinely live. So I've got. Let's say this is X and Y, and actually I'm going to add a bounds, and I'm going to say that -10, and then +10. So inside this is a silly place for, it is a silly place, but actually, so actually I'll change my maze definition to have like a bound, and I'll just say that it's 10 by 10. It's a 10 by 10 matrix. Now, and I've got an X and a Y. X is node 0. I just want to double check one thing that, yes, it is. Okay, good. I've got the right variable name. Okay. Node.0, and my Y coordinate is node 1. So I'm actually accessing the fields of the, I can do this, I think, in a way that's slightly more, I'm accessing the fields of the tuple, the node argument, and assigning them to local variables. Now I want to be able to create some vector of neighbors, and I'm just going to give it the variable name others so that it doesn't look exactly the same as the the method name itself and we don't get muddled up. And at the end of the function, or end of the method, I'm going to return others as well. So if x is greater than 0, and just say there's an implied bounds for 0. Oh, it's a silly thing to do. I should have x bounds and y bounds, but we don't. Then I want to add a others push, and I've got x plus 1. Oh, no. Wait. X minus 1. And then and this is also an and x is less than or self dot bounds zero, and then y is the same. Now I don't think I should do the entire graph because this will get boring very, very quickly. But you can sort of see that we're building up a list of neighbors, and we are maintaining very little internal state. So if y is greater than 0 and y is less than self bounds 1.
Yeah, this point about the internal state is actually very cool because, often it's tempting to kind of dump as much data as possible in a struct, but which is like, I think is again, I'm not a Rust expert, but I think it's a perfectly kind of reasonable thing to do in some cases, right? But here, what is really great about the code that Tim is writing is that, first of all, it's generic enough to do some pretty crazy stuff with mazes, which is over my head. But on another hand, right, it's like the fact that Tim is encoding a lot of stuff in computations rather than dumping a lot of data in the structures. It kind of, as far as I can tell, helps him to kind of sidestep a lot of issues of that you can get into when trying to prove to Rust Cs that your code makes sense in terms of ownership and borrow rules.
Now I want to do one. Oh, thank you so much. By the way, I want to do one other thing, which is we're going to add a side effect inside our DFS. Implementation is that we're going to print out our current position. Now, in order to do so, I actually need to add another constraint to... So this way, it will actually do something interesting when I run the breadth first search. Otherwise, it just is completely... it's actually not very interesting. So I need to be able to ask that our node can implement standard format display. This is not part of the core algorithm, but hopefully we can actually see something.
And it also brings us to a rather interesting point, which is that in Rust, as opposed to Haskell, where in Haskell we just have show type class, right? And something is either showable or not. Whereas in Rust, I don't know yet. In Rust, they actually have two type classes or two traits, I guess. For that, one is display that Tim just mentioned, and the other is debug. And you can actually encode different behaviors for your. It's a small thing, right? But it's very powerful because you can now encode completely different printing mechanisms for stuff that you want to actually, display like in production versus something that you just want to look at as a developer while developing your system.
Absolutely. So the really interesting, so just to explain that distinction, the display trait is intended for end users. Well, at least it's so you can use this to be able to implement logging, for example, or actually not so much logging, but just output that is designed to be intended for people outside of the developer team. Whereas the debug trait is intended for people who are writing the software to be able to inspect their own code. And so I've requested that my node type implements display, because I want end users to be able to see the progress of my nodes going through. Now, that isn't necessarily, I mean, in some sense, it's somewhat arbitrary, but let's, I think, now we haven't actually compiled this. So we haven't even saved it to the disk. I am curious as to whether or not I'm going. Hopefully, I don't look like a complete idiot here. So if I run back,
yeah, sorry, a second of Nick's quirks.
That's right.
Yeah, we're in different shells right now, so we need to do this.
Okay, so Rust C. I'm in a DFS. Oh no, we're actually breadth first. Goodness me. Okay, so we've got us a couple of type errors. So the first thing that I need to be able to do is, I'm just checking. Okay, so in this, okay.
Oops, I'll exit.
Yeah, yes, please. Sorry, yeah, I've got it. Yeah, if you could get us back into the right place. Okay, so what has happened? Okay, the first thing is that Rust is very confused because I have implemented. I've asked Rust to define a function BFS that takes a graph object, or something that but graph is not a concrete type. It is, I need something which implements graph. Now, I think this will, can we try this one? This should get us somewhere. If I,
sure, I'll just click Control Z, yeah, and then
yeah, that's right. Yeah. Okay, so we've got one of the, and so I've actually got the wrong, so I've got a, okay, good. Yeah. I can.
Yeah, we also need to, I think, import hash trait.
That's right. So what is a hash trait? Well, we've actually explained this. So a trait is an abstract. You could think of it as a type class from Haskell, or if you're from sort of a Java background, it would look a lot like an interface or an abstract base class. Rust traits are a little bit more powerful than interfaces in Java. But one of the things that you're required to do is bring them into local scope. Otherwise, which kind of means that, so now I'll write again. Okay, so
I'll run it, yeah.
Semicolon. Okay, we need to change the thing. Okay, I think that.
Yeah, so the interesting bit is how to tell it that it's the same graph, I understand, right?
Yeah, that's right. That's correct. So we've got I've got an extra semicolon somewhere in line 36, and I'll get rid of some easy things. Just in the struct. And down here, it's not DFS, it's BFS.
I bet that our sound engineers are already excited about like editing for the podcast bit. Yeah, Tim, don't worry. We have people who are who love me so much right now. But yeah, don't worry. We'll figure out how to edit this stuff out. So
yeah, I apologize for this. It's quite.
Oh no, I mean, but to be honest, like it's so much better than not having these compiler errors, right? If it would just run and then spit out random stuff, we would be here till tomorrow.
Absolutely, yeah. Now, This is actually, I don't. So the problem that we've got is that we want to implement graph. I think this is right.
Yeah,
although
I think that
the problem that we have is that our start variable is of an associated type relating to graph, but the inference algorithm gets a little bit confused. I think this isn't the right way to say.
I think shouldn't we just say, so basically what Tim just did, he wrote that he wrote that the BFS function is parametric in type G, which he said should be of trait graph, implement trait graph. But can't we just use G everywhere now? Can't we just write like G is of type G and like this is of type G now? Or what's the problem?
Yeah, okay. So the difficulty becomes, so like, why can't we use G colon node? The problem is that, okay, so the trait, the G is a concrete type which implements graph.
Yep.
However, and yes, I think that so this one here could just be. So are you saying that
just G? Yeah.
This one.
So instead of impl graph, like.
So this is no longer dynamic dispatch; it's statically dispatching on so on the concrete type that implements graph, and then the G graph. Actually, I'm interested. I've actually found I'm a little bit confused. I'm struggling to remember exactly whether or not this is legal syntax, but we can try this. So what I've done now is replace the trait object, which is called a trait object. It's just a you know about the way that functions are or dynamic dispatches. Oh, this is good actually, because
we have completely different errors now.
Yeah, so the okay.
NQ, by the way, NQ is like pop front, I think, push. They have push front, push back. Yeah. And maybe this is actually something that confuses my mom a lot when she sees me programming, or she used to see me programming when we were living in the same place. I would have errors, right? And then I would get more errors, and I would be like, "Yay!" And my mom would be like, "Well, these were errors, right? And now you have like even more errors. Why are you so happy?" And I'm like, "These are different errors. How come?"
Yeah, which means that we've fixed the problem that we wanted to start with. That we had originally. So the enqueue method becomes push front, and the other one, so we can save that, and then
it's also complaining about stuff like inserting a thing versus like inserting a thing versus inserting a reference to a thing. I think.
Yes. Okay. I want to change one other. Do you remember when we talked about display versus debug? I'm going to change things around and implement debug, because it's simpler. I mean, it's implemented by more traits, and in particular, the tuple trait that I've defined for Node has it automatically defines. It's automatic. The compiler will implement debug on our behalf. So this. Oh, sorry. No. Carry on. Mm-hmm. Yeah. If you compile now, we should just have the reference errors. Okay.
Let me scroll about a little bit.
Yeah. So that we've got.
So we just have the reference errors. Yeah.
Okay. So that should be. The problem that we've got is inside our implementation of neighbors, we've taken a reference to Node, and so our variables x and y are actually references to are actually references to some numbers that exist. So I wonder if I dereference node right at the top, then all of these things should, yeah, great. Okay, we compile. Great, cool.
Oh wow,
So,
that was really really cool. Because whenever I have this sort of issues, I go like, oh, I will clone a bunch of things. I'm very I don't know why, but I'm like very scared of like dereferencing.
This is a silly place for me to start. May I should just change all of my tests only add neighbors if I'm above 0. So I need to change the starting position. That's
Probably,
why.
yeah.
Actually, I should just say that if I am below bounds, but I'm only going down, so I'm going to start at 5.5, let's say. Or 5.8, just to be interesting.
Nice. Oops, we need to compile it first. Okay, you do the honors.
Okay. Yay! Okay, so we traverse the graph. Yeah.
Wow.
So that is breadth first search implemented in Rust.
Wow, that was honestly, I imagined a lot of things. I imagined, that exceeded my expectations for one reason, because I thought that you'll be like kind of boring, and we'll say, like, we have limited amount of time, so let's just get some concrete type, some concrete adjacency graph, and then traverse it. But actually, this is beautiful. Thank you so much, Tim. Honestly, it's yeah, yeah, thanks. I guess we can go to the interview part. And by the way, we will put.
No, you should go to. Don't you need to go to sleep? I imagine.
I mean, let's just go really briefly over some questions.
Okay.
And of course, we have questions from the audience. This is like maybe even the most important thing. But yeah, I just wanted to say that this code will be available in Teams, on Teams GitHub or somewhere. We will make sure that you can all enjoy it, because honestly, it was really cool. All right. Let me turn on my camera. Hello, everyone. And let's go through some questions. I mean, I would actually like, I have, there's not going to be a lot of questions, but one thing that I noticed that we talked about while you were implementing this stuff is how there are some tricks, right? You could even say patterns, right? Like, for example, the stuff that we talked about when you don't know who will own the thing. Like, we introduced like a kind of, as you called it, manager entity that would own then everything in the structure. So, and in general, when I was like in the beginning of my career, when I was just learning programming, programming patterns were like the hot thing. Like, everyone was drawing like UML diagrams also, all this stuff. And as I kind of moved to functional programming, all of this stuff reduced, no pun intended. So do you think what is your take on like programming patterns with Rust? Do you think and in general, maybe?
So I think that there is a place for patterns in the way, insofar as saying that we, as a programming profession, let's say, or as people, well, because we work in teams, we need to be able to write code that others in 3 months or 3 years' time are able to understand. It's very difficult to write code that is readable by others. It's actually, and so the benefit of patterns is to be able to in some sense, create a common vocabulary in the programming community about, things like iterators, for example. It's so commonplace to have types that actually know how to iterate over some collection that many languages no longer actually require you to implement an iterator. And so that's useful. I think but like everything there, it's detrimental in some other senses, because if your problem does not fit the pattern, you find that actually you've sort of painted yourself into a corner of a room. I don't know if you've ever tried painting a house or actually cleaning. If you're mopping the floor, that's a better analogy. If and you kind of clean, and then you get to the corner, and it's like, well, I'm now stuck because I'm trying to implement a pattern. That's when it becomes a problem. Or if you, I think there's a level of, there is I'm trying to figure out how to describe this. One issue that you will encounter as you become more proficient in Rust, or in a language that respects or has a robust type system, you will have a tendency to over abstract, or to create very elegant and very things that will these abstractions, which are in some sense very nice, but actually they obscure your intent. At least that's my experience. That I think when you begin programming, everything is it's all concrete types, it's all kind of simple. So you then learn some more skills and you pick up bigger problems, but then your tendency is to always reach for these very, very complex systems. And then advanced programmers will come sort of the swing back to simpler methods. And I think patterns are very useful for people, for teams, and for people who are learning how to program. But it's also important to remember that they are not rules, or the intent is not to restrict you, but actually to kind of provide you with more flexibility.
Right. And well, you wrote by now 2 books on Rust, right?
Well, no, no. Well, I've got Rust in Action.
Okay. Oh yeah.
But that's the only book, the full book that I've written.
Right.
But there is actually another one, but we're still, it's not, yeah. So it's not completely public yet. It's actually not public yet. So, but there's one coming. So by the end of the year, there'll be something else. As long as my family, I've got little kids, I've got a career, I need to be able to, have a social life as well. So we'll see.
Yeah, that's one of our biggest interviews was with Sasha Yurich, and actually we were hanging out a lot as he was writing the book, and he was saying that for his first book, it's the amount of time it took him, he underestimated it by an order of magnitude, basically. Something along those lines.
For me, it will be close to an order of magnitude. So it took me nearly 5 years. No, because it took, for various reasons, it was about a year before the project officially got started. Originally, I was brought in by Manning as a second author. So there was a project that they had, a Rust in Action project, 2015, I think. But that was already, but the first author actually pulled out. So we were working together for a couple of months, and then the first author kind of pulled away. And then the publisher said, do you want to carry on? I said, no, we should write a better book. The manuscript we got so far is kind of rubbish. But then my own thing, I had this idea that I wanted to write the best programming book that I had ever seen. I wanted to convince myself that it's possible to write an excellent book, and that I had sort of noticed that the trend in technical publishing had been declining over a few years, I think things that were published in like the late 90s were probably a lot better than things that were published in, say, 2012 or 2013. And I wanted to be able to write a book that I would want to buy. That's really difficult. So the reason why books of quality has been declining and it's getting faster and faster is that it's simply hard. It's really, really hard. So I spent, I would estimate between 5 and 10 hours a week over, in fact, no, 10 to 15 mostly. So I tried to do 2 or 3 or 4 nights for 2 hours a night, plus some period in one of the weekend days, which was like about a 3 to 5 hour period. So that, let's estimate that roughly 10 hours a week. For 4 years, that's 2,000 hours.
Wow.
Like that's, yeah. And like it doesn't stop. It turns out that once you've written the book, you then need people to, like, you need to advertise it. Otherwise they don't buy it. And then it's useful. It looks useless. However, Rust in Action has done extremely well. Most technical books I sell fewer than, say, 5,000 copies over their entire lives. I've sold, I think, about 20,000 copies in its first 6 months. That's Rust is growing. Rust in Action is a good book. It's different than every other book. But yeah, so hard to do. It's actually really, really hard.
So do you, when you say that it's different, well, first of all, it's really great to hear that you're making the return to the glorious books of 90s and drawing inspiration from back then. Because I remember, like, for example, Linux core Linux reference, but basically reference manual and or C++ reference, right? Those are references, but those are well-written, narratively well-written books as well at the same time. It's just mind-blowing how good they were, right? So that's great. And also, like, maybe for our viewers and listeners, like, do you emphasize in your book, like, kind of tricks and tips, like, kind of, do you add, like, to the explanation of what things are, the explanation of how to go about, like, actually working with these things?
Yeah. So I want to answer your question, I think, in 3 ways. So first of all, the book is different primarily. So it came out. I was starting it when the official book by Steve Kladnick and Carol Nichols was nearly finished. It hadn't published. I wanted something that was different than that book. Like, there's no reason to spend money. I mean, mine is not a free web book, right? So it needs something extra. And I thought Rust is being promoted as a systems programming language. And so I want to teach people who had only used JavaScript or only used Python or only used, let's say, Java or C# or anything else. And they were looking at Rust and saying, I'm scared of systems programming. I'm scared of I've heard that systems programming is hard. And what I wanted to do was teach people enough of that so that they don't get intimidated by the jargon. And so that's one of the ways that my book distinguishes itself. The other thing is that does it provide strategies? Well, actually, I think in chapter 4, it's devoted on, like, ownership and borrowing. And I go through 3 different methods for resolving issues around ownership and borrowing for beginners. I think one of the things that also makes me what's my book a little bit different, it's kind of the third way, is that I wrote it for myself. I was a Python programmer before I was a Rust programmer. I did natural language processing. I wasn't even a real software engineer. I was a data scientist. I wrote Python for being able to do text analysis, and it was too slow and used too much memory. And so I decided to start writing Python extensions. But if you read any material on writing native extensions for Python, on the C extensions for Python, there'll often be a paragraph which says this is very dangerous. You might crash your program. If you might introduce memory leaks. You might do this. You might do that. Effectively, you'll crash your computer. You'll introduce security holes. And so Rust provided me, and I sort of see myself as like Rust provided me as like an everyday non-programmer. Like I'm not a professional professional computer scientist. I have a humanities degree. I don't have a computer science degree from university.
That's a bit of a topic in our podcast. Actually, like 3 of our previous guests, including you, are not trained as computer science. Sorry, go on. Sorry.
Yeah. So I wanted a book for me. And there are better Rust programmers in the world than I am. My book was written for people who are still learning, and I definitely still remember learning. And I hope that I did not have kind of this expert blindness problem. I think if I read a book by someone who is I find books that are written by professionals or people who are extremely good, often very difficult to read because they have forgotten what it is like to learn. There's so much there. Learning Rust is more than a programming language. It involves learning a lot of jargon. It involves understanding some new concepts like ownership and borrowing, for example. And so there's almost multiple layers of learning that are required. And my big message to people who are interested in this new high performance programming language is that they should take it slow and just learn things piece by piece. And also that if they don't end up using Rust, actually they haven't lost out, because you can apply a lot of the techniques, in particular functional programming, to other domains or other programming languages as well.
Right. Yeah, absolutely. Yeah, for sure. And if I would if I could humbly add something to your message, when you said take it slow, I would also suggest complete beginners to also not be scared of cloning your data or copying your data. Because if you think about it, I had this huge problem that, I'm writing Rust. It's kind of an imperative language, and I must squeeze out every single byte of memory. Like I must not even prematurely optimize, but I must everything that can be mutable must be mutable, within boundaries of a module, let's say. But it's actually false. Like you can clone so much, and your Rust programs will still be 10, 100 times faster than your, PHP, Python, Java programs. Because no matter how much even compiler optimizations aside, no matter how much you will tell Rust to clone your stuff, right? You will not manage to clone your stuff as much as let's say a virtual machine where, you just copy and change everything pretty much. So yeah, don't be afraid of taking it slow, in practice, and don't be afraid of making it slow by cloning a bunch of things.
Absolutely. I mean, the cloning, there's this idea that cloning is expensive or cloning is slow. It takes 20 nanoseconds. You can fit hundreds of them inside a millisecond. It is slow compared to for the CPU, and yes, it is slow compared to just kind of copying data, but it's not slow from the point of view of your users or you as a programmer. And there's also plenty of time to learn more, techniques that don't require clone. But for now, absolutely, clone or toString or toOwned, these methods are there for a reason. And the reason is often that they're useful. So use them.
Yep. And in general, sometimes people are scared of Rust ergonomics, but actually, if you kind of take time to appreciate how many options you have, as Tim mentioned, when you are writing Rust programs to like write meaningful program reasonably quickly, you will see that ergonomics are there. And in my opinion, for example, immutability by default is like just an ergonomic tool. It kind of nudges you in the way like, okay, like don't worry about it. Just create a bunch of stuff, use it, and it will be, the memory will be freed, by the Affine design. So yeah. I think those are good messages to wrap it up and go to the questions from the audience. But yeah, I mean, Tim, before we go to the questions, is there anything you deeply care about that you'd like to advertise, like maybe aside from your book? Because I hope that we'll do pretty good job advertising your book also.
I would be very interested in learning how people, and advertising, maybe not. I would say, tell me about things that you're doing with Rust and any problems that you're encountering. So I think I would love to hear from you. Either, I think the easiest way is probably Twitter, and we'll probably have a link to my Twitter account. But the easiest way to find me is through Tim Clicks, TIMCLICKS, and I'm always very receptive to people's messages. And yeah, the other one would be the YouTube channel. So it's the same. It's YouTube / Tim Clicks, or and that will get to me there. So you have similar things to me implementing search algorithms. I haven't done yet, but similar things I have, and I'm always interested in new ideas. So please send those through.
Right. Well, and I actually also have something to advertise, which is this podcast.
Yes.
I mean, we're making this podcast, or at least we're trying to make this podcast for every single listener and viewer. And for example, subscribing will give each of you a chance to engage with the guests in real time, ask questions in YouTube chat, and also, just as Tim said about engaging with him, also engage with us. Ask follow-up questions, share your opinions in emails, talk to us on Twitter as well. Like, we are all one big, awesome community, and I think that just maximizing the potential of our kind of engagements is a very, very good idea. All right, now let's go to questions from the audience. We don't have that many of them. So, and the current questions I see, they are related to the coding section. One is, are we making a path map? It's, I guess, about the maze bit.
Yeah. So I'm actually not sure exactly what you mean by path map. I think yes, we can create paths through. We can actually use a depth first. Actually, a different search algorithm called depth first search. We can actually use to create a maze. Breadth first search will be able to traverse every node in the graph, so it will be able to completely search through the entire thing. That's what we've done so far. And so the only kind of strange thing that we've done in our implementation is not actually store the nodes themselves. We just create them on the fly.
Yeah, we had like this kind of quote unquote generator function, and it might look a little bit confusing. I mean, it was, as you were writing it, actually it was confusing, but then it clicked when I understood why you're doing these checks. But yeah, basically we just generated a bunch of stuff like on the fly, and just as a demonstration that this stuff actually works. And another question is actually very interesting. So the other question is there no constraint kind in Rust? So I don't know if, Tim, do you know what constraint kind is?
I have not used high-kinded types myself. I'm not a Haskell programmer.
I'll just provide context, maybe also for the listeners, for sure. It could be useful. So basically, when you write out something like I don't know, like something like functor or whatever, or graph or something, right? That you would have like kind of type variable, and you would then insert this type variable in that constructor, and you will get like, okay, and the kind of this kind of functor or whatever that takes like something as like some type variable, the kind would be asterisk into constraint,
Right.
right? So this is so it's not just asterisk to asterisk, or at least not anymore. I think that like 10 years ago it was just asterisk to asterisk, but now Haskell can actually say, oh, okay, the result of applying this type to that type like to that thing that expects that has like a slot for type variable, the result of applying this will be constrained. So I guess the question is there is there a similar way, is there even a way to reason about, I guess, kinds in
Not to the same extent. And so Rust's type system is not as sophisticated as Haskell's. There have been discussions that higher kinded types will there have been proposals made to be able to do something similar in Rust. Rust, the shortest answer would be no, but you can do things that are similar with enums. So we have some types in Rust, which just happens to, I think, use the wrong keyword, enum, and you can provide, in some sense, a form of restriction via some of those variants as well. We haven't demonstrated that in the code that I've shown before, but that would be the closest, I think, just thinking about it, is that you can emulate higher kinded types, but you can't get to the same extent. It's not quite as natural as Haskell.
Well, thanks for insightful information about the fact that they are trying to add them, and also maybe it's a topic for to attract Haskell crowd, right? Like to your YouTube channel, emulating higher kind of types and Rust. And yeah, another question that I understand that this is the last question that we have, unless the producer will correct me. So the final question is from someone who's very like practical about learning stuff. So there's a very popular approach of like learning by building, right? So the person asks, like, kind of what's the best way to go about learning Rust, and like what projects, in the context of like what projects could they try to build to learn?
So I don't want to promote so this is lovely book. No, so one of the things that distinguishes Rust in Action is that you build a big example in every chapter of the code, every chapter of the book. And so we build a database, we build a CPU emulator, we implement a HTTP like multiple times. And every time we remove one layer of abstraction, and by the end, we're actually we're sending like TCP requests ourselves. And so, if you're the kind of person who likes projects, Rust in Action is your book. There are free resources, so there are several things. There are several. One that I like is there's a tutorial for creating a text editor in Rust. I think it's and I'll send the link through to the team for later. And there's also a really lovely book related to games programming called Hands on Rust. And Hands on Rust is I think it's called Hands on Rust, Effective Programming with Rust or something. It implements a 2D platform game, and it's quite fun.
Yeah, that's really cool. Actually, we have one more question, and for our current viewers who are live, again, this will be edited out, but rest assured that we will get some way, so that you will get, after we get into post-production, you will get some way to like get Tim's book for free if you're eager enough. And we have a couple of promo codes, and we will announce it when we are done with producing the final video and producing the podcast episode. So stay tuned for that. I mean, actually, I don't know. It's honestly, your book sounds so fun. Yeah. Anyway, I know what I'll be doing today before I go to sleep. But anyway, so so the final question for reals now, I promise. As a functional programmer, okay, I'll do it once again for the editing team. So the real final question is, as a functional programmer, are there ways I could leverage my previous experience to kick off learning Rust?
Yes, very much so. So Rust prefers higher order programming and a functional style over almost all of its collections. And so you may think of Rust as an imperative language because it is normally associated with C++. However, Rust was originally an ML. It was implemented first in OCaml. And so a lot of your functional learning will flow through into Rust quite naturally.
Yeah, I personally for myself, like again as a Rust beginner, I found out that kind of the way we write functional Python, I know it's kind of weird, but like you have kind of functional wrappers around like kind of imperative, sometimes imperative like loops when it's just convenient to or effective to modify something, like modify some dictionary and have like a functional API or a functional interface to it. Again, in my like kind of beginner experience, this is what I do in Rust a lot to a pretty good success, which means that then you will compose those functional wrappers together pretty much like as if you're writing Haskell or something like that. But yeah, I don't know. I mean, I guess this is a reasonable take on that. So yeah, thank you so much for joining us, Tim. It was a huge pleasure to talk to you, and sorry for that like impromptu coding session. But I mean, you succeeded. It was like I'm still in awe, and the fact that you made your implementation generic was also very, very cool. So yeah, thanks for coming. Yeah.
Wonderful. Hey, I've really enjoyed it, and also big success with the rest of the podcast. I'm looking forward to looking through your previous episodes and subscribing for more.
Thanks. Thank you very much.
Okay. Bye-bye.
Bye.